Problem 4. How many distinct positive integer pairs x, y have the property that the sum of 5x and 7y is 500? Alright, well that looks kind of like a straightforward algebra problem, right? 5x plus 7y equals 500. But the problem is we have two unknowns and only one equation. So let me give you a hint on this one. Whenever you're dealing with these types of integer problems, all right, so we're dealing with discrete values, integers. So x and y are integers. They can't just be anything. You can't have an x of 2.65 or anything like that. They have to be integers. When you're dealing with integer problems, it's often a good idea to look at the factors. Okay, so like for example, this 500 is 5 times 100, which is equal to 5 times 2 squared times 5 squared, right? And so we could write that as 2 squared times 5 cubed, right? So you know that this, the prime factors are 2 and 5, so you know that you ought to be able to factor a 5 or a 2 or 4 or an 8 or a 15 or a 10 out of here. And I can see that a factor of 5 in this term. So what I want to do is take the factor of 5 out, okay? But the thing is that when I take a factor of 5 out of this, I get 7 over 5, right? And that's equal to 5 times 100, okay? And the reason I can do that is because of the fundamental theorem of arithmetic, which just says that every positive integer has a unique prime factorization. Okay, so if these two sides are equal and they're both integers, right? So I know that the factors on this side have to be the same as the factors on this side in the end, right? So I can factor, if there's a factor of 5 over here, I can factor a 5 out, okay? So, and these will still be integers. Okay, so this will still be an integer, this x plus 7y over 5. All right, and I can actually just divide both sides by 5, and then I'll get x plus 7y. Let me just rewrite it. X plus 7y over 5 is equal to 100. Okay. Now we know y has to be an integer and x has to be an integer, and it's equal to an integer. So we know that 7y over 5 has to be an integer. Okay, so this whole thing has to be an integer. So what does that tell you about y? Well, it tells you that y has to be a multiple of 5. Otherwise, it's going to be a fraction, right? Because you can't factor a 5 out of 7. So the factor of 5 that has to be in the y term in order to make this an integer. So y has to have a factor of 5. Alright, so let's work with that. So let's just write out our little table of x and y values. And we know now that y has to be a multiple of 5. It has to have a factor of 5. So, and it has to be a positive integer. So that rules out 0. Okay, I know that 0 could be a multiple of 5, but 0 is not positive, okay? It's a good thing to remember that 0 is not really positive. It's not negative either. It's just sort of out of no man's land. So let's start with 5 and 10, 15, 20. Okay, well, I'll just do that many for now. And so if y is 5, then we just get x is 7, right? Or sorry, we get this term is equal to 7, and if we subtract it from both sides, okay, so this becomes 7 times 5 over 5, which is just x plus 7 is 100, which would tell us that x has to be 93, okay? So now let's try 10. Well, then we would have 14, x plus 14 is equal to 100. If we subtract 14 from both sides, we'll get an x of 86. Okay. If we use y equals 15, we get 15 over 5, which is 3, times 7, which is 21. So if we subtract 21 from 100, then we get 79. And we'll do one more. So 20 over 5 is 4, times 7 is 28. If we subtract 28 from 100, then we end up with 72. Okay, so that gets us started. Now we can keep going. Now you could list these all out one by one, and you can see these numbers are going down, and we want these to be positive integers, so we're eventually going to reach 0 and go negative. So so I'm just going to put a dot 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 here for now, because I'm lazy and I don't want to write all those out. And you know, most mathematicians are, you know, basically lazy, right? I didn't write all this arithmetic. Okay. So anyway, let's figure out what the other extreme is. And I'm actually seeing a pattern here. This is an arithmetic series, right? So we were starting with 93, and then you can see there's a difference of 7, a negative 7 here, a negative 7 here, a negative 7 here. So we can actually write an equation if we say this is, if we number these, and we can say this is n of 1, 2, 3, 4, and so on, then we can actually write an equation for x in terms of n, okay? Because it's an arithmetic series, which is it's easy to work with. So I have a video on arithmetic series in my under lessons on my website. So if you want to learn more about arithmetic series, you can go look at that. But we can actually write an expression for this. So we can say this is 93. Okay, the first term when n is equal to 1, then you know we're subtracting 7 every time. Okay, so when n is equal to 1, then this is 0, and so then it's just 93. When n is equal to 2, 2 minus 1 is 1, so we subtract 7 and it's 86, and so on. You know, if n is equal to 3, we get 3 minus 1 times 7 is 21, so subtract 21 from 93, so we get 70, and so on. Every term is just 7 less. Okay, so let's see if we can find the smallest term here. So let's find what integer let's look at the integer multiples of 7 and see how far we have to go to get under 93. Okay, so let's look at that. Let's look at let's say if we were to take 100 and divide it by 7, what do we get? We would have let's see, 7, 30. So 14 times 7. If you take 14 times 7, you get 98. Okay, so so 98 is a multiple of 7. Okay, so if n is 14, okay, so if we say 93 minus 7, 14 minus 1. Now we know that if n was 15, this would be you know, 93 minus 98, which is negative. So let's try 14 minus 1. So that's 13 times 7 minus, so 13 times 7 is 21, oops, 91, right? So so that would give us 93 minus 91, so that gives us 2, all right? So we know that this series will go all the way down to 2, all right? And that it will be 14, n will be 14 when x is equal to 2. And I mean, if we go any further than that, we get negative values. Okay, so we can actually check that out and see what we would get for y. So if we use x equals 2, and let's just plug it up back up into this equation up here. So 5 times 2 plus 7y is equal to 500. Alright, so this is 10, so this is 49. If we subtract 10 from both sides, that's 490, 7y, so y has to equal 70. Alright, so we could write 70 in here. So we know that 70 times 7 plus 2 times 5 gives us 500. Okay, and then so we can count the number of numbers in this list of pairs, xy pairs, by looking at n. Okay, so there you go. That's the answer. This is kind of a tricky one, but remember when you're dealing with these integer problems, oftentimes finding factors and using the fundamental theorem of arithmetic is the key. So there you go.